हेलो नमस्कार नमस्ते बच्चा लोग. Hi, this is Shailesh Sir here and I am making this video for the Unacademy Star program. So बच्चा, in today's video we are going to discuss about a very interesting and a very important topic of basic thermodynamics is various thermodynamic process. As you know that very well, for GATE, engineering services and similar engineering competitive exams, thermodynamics is a very important subject. And for understanding the basics of thermodynamics and application part of thermodynamics like IC engine, power plant and your refrigeration and air conditioning subject, we need to have a very strong basic of various thermodynamic processes, because all the cycles that we are going to discuss in thermodynamics and application part of thermodynamics are based on to one or the other processes. So in this video, we are specifically going to discuss with you about the 5 types of processes. I am going to discuss about the processes. First of all is the constant volume process. Second one is the constant pressure process. Third one is the constant temperature. Fourth is the adiabatic, and fifth one is polytropic process. After this completing of 5 processes, you will be able to physically visualize the process, understand the key equations that are very important to solve the numericals based on the given process. So यहाँ पे we'll start with the first type of process, which is also called the constant volume process. So बच्चा, what is the constant volume process? यहाँ पे मैं आप लोगों के लिए लिखता भी जाता हूँ. Sir, the process in which the volume remains constant. So volume remains constant means the change in volume will be equals to 0. Volume remains constant means the change in volume will be equals to 0. And बच्चा, आप लोगों को यहाँ पे इस प्रोसेस के दूसरे नाम भी याद रखना बहुत जरूरी, like the constant volume process is also known as the isochoric process or the isometric process. Isochoric process and isometric process. Now bacha, let's understand that how can we physically represent a process, because many of the times in the examination they will not directly say that this process is a constant volume process. I'll give you an example also after explaining you what is the physical representation of the given, you can say, constant volume process. So let me explain this to you. So बच्चा, let's understand. मान लीजिए if you are having a rigid container, let me take some shapes and explain you. So मान लीजिए if you are having a container, this is a rigid container, okay? And I am marking its boundary. कंट्रोल वॉल्यूम मार्क कर रहा हूं. So बच्चा, let's say we are having any gas which is having volume, for example 10 meter cube. Let me show this with dotted lines. So बच्चा लोग, if you are having a rigid container and now you are supplying the heat, when you supply the heat, so बच्चा, the gas cannot expand, and when the gas cannot expand 100%, you can never have the displacement work. So यहाँ पे for any gas undergoing an isochoric process, बच्चा लोग, the displacement work will be equals to 0. WD, the displacement work will be equals to 0. ये आप लोगों को याद रखना है that for, you can say, any gas represented by the closed system undergoing an isochoric process, the displacement work will be 0. But जैसे आप लोग heat supply कर रहे हो, as you are supplying the heat, what will be the result, sir? The result will be the increase in the energy of the system, and because of the increase in the energy of the system, we can say that your temperature will increase. क्या होगा बच्चा? So isochoric heat addition will lead to the increase in temperature. Is this clear बच्चा? Now बच्चा, ये है आप लोगों का फिजिकल रिप्रेजेंटेशन का एक तरीका. पॉइंट नंबर 1, where the volume of a given gas cannot expand. And इसका एग्जांपल भी मैं आप लोगों को बताना चाहूंगा. In the examination they will be giving you an example of, you can say, either a football or a vehicle tire. So where the gas cannot expand, that can be considered to be the best example of a constant volume process. Is this clear? There are many of the questions coming on to such phenomena. Okay. Now sir, what is the other way we can represent a constant volume process? So bacha, for this we can have the piston cylinder assembly, which will be having the stoppers on both the sides. So let me draw the diagram for you. This is your cylinder, and let's say I am drawing a piston over here. Now I will have to make the stoppers on both the sides. So bacha, when you are having stoppers on both the sides, now piston can go up. That means there cannot be any expansion and there cannot be any compression. So let's say if you are having a gas inside, so bacha, if I am representing the fixed region for analysis, so I can mark the boundary like this. Okay, I can mark the boundary like this. See, small things, when you are able to understand in a proper way, makes your concept more stronger. Okay, let me try to make the dotted lines for this. So बच्चा चलो यहाँ पे इतनी डॉटेड बना रहा हूँ, otherwise it will, you can say, affect the complete line. So let's say once again you are having a ideal gas only. In this case also we are saying that we are having an ideal gas, and let's say the volume is 5 meter cube. So once again when you supply the heat, so for an ideal gas undergoing an isoporic heat addition process, once again the displacement work will be 0. Over here the displacement work will be once again 0, because the given ideal gas cannot expand or even it cannot compress. Okay, so that's why we can say that आप लोगों का, okay, over here your displacement work is equals to 0. ठीक है बच्चा. Now there is a very important key point, as you know that very well, that whenever an ideal gas is undergoing an isoporic heat addition process, we had seen that overall the complete heat supplied is utilized to increase the energy of the system, because according to the first law the heat is not at all getting converted into the displacement work. And bacha, we know that very well, we are going to discuss this later on, that your internal energy is directly the function of the temperature only. So as you are supplying the heat, first of all the energy of the system is increasing, and sir, due to the increase in energy of the system, sir, the internal energy of the system is also increasing. Sir, the internal energy of the system is also increasing. Now we know that very well, that internal energy of an ideal gas, I am saying it very clearly bacha log, that internal energy of an ideal gas is directly the function of the absolute temperature, and that's why when the internal energy of the system is increasing, then the temperature of the system will also increase. So bacha log, the bottom line conclusion is that for an ideal gas undergoing an isoporic heat addition process, the temperature of the given gas for a given considered system will increase. The temperature of a given gas for a given considered system will increase. Is this clear, bacha? I hope this point is pretty clear. So first of all, I am writing this over here only. Sir, for an ideal gas undergoing an isoporic heat addition, for an ideal gas undergoing an isoporic heat addition, process, sir, point number 1, the temperature increases. Sir, the temperature increases. Sir, what happens to the pressure? अगर आप लोग ideal gas equation को apply करो, if you apply the ideal gas equation, sir, what is the ideal gas equation? I am just writing over here, which I will rub it out. Sir, PV is equals to MRT. So यहाँ पे let's say we are having a fixed mass of an ideal gas. So this is constant. Characteristic gas constant R is also constant, and it is an isobaric process, bacha. So volume is also constant. So can we say that the pressure is directly proportional to temperature? This we are going to discuss in the later stage of the constant volume process only, because we will define the first ideal gas law from this. So bacha, as the temperature increases, then the pressure will also increase. As the temperature increases, the pressure will also increase. Is this clear, bacha? So the pressure also increases when the volume remains constant. When the volume remains constant. So this is very important conclusion. For an ideal gas undergoing an isoporic heat addition process, the temperature of the ideal gas increases, the pressure of the ideal gas increases, and the volume remains constant. बच्चा लोग, is this clear? Is this clear? तो ये आप लोगों को याद रखना है. Now one by one we will draw the constant volume processes on your different diagrams. I will draw the constant volume process onto the different diagrams. So let's say first of all we are talking about the PV diagram. सर ऑन द पीवी डायग्राम आप मुझे खुद बताइए कांस्टेंट वॉल्यूम प्रोसेस कैसे होगा. सर कांस्टेंट वॉल्यूम प्रोसेस विल बी 100% represented by a vertical line. Yes or no? But sir, we want to know that very well. What will be the direction of the arrow when we are having a heat addition process or when we are having the heat rejection process? बच्चा लोग, okay sir. So bacha, let me just plot everything for you. So bacha log, when we are plotting everything properly, so you can understand the things in a better way. Okay. So see this bacha. So bacha, if we are having the isoporic heat addition and isoporic heat rejection, so बच्चा लोग ओके बच्चा लोग, सो बच्चा फॉर एन आइसोकोरिक हीट एडिशन प्रोसेस आप लोगों का जो एरो बनेगा, सर द एरो विल बी पॉइंटिंग वर्टिकली अपवर्ड. ओके बच्चा, सो इनिशियली आप लोग जो पहले देख रहे हो, फॉर द हीट एडिशन प्रोसेस द प्रेशर विल इंक्रीज, सो द एरो विल बी पॉइंटिंग वर्टिकली अपवर्ड. And for the heat rejection process, sir, the arrow will be pointing vertically downward as the pressure decreases. Is this clear, bacha? Then, sir, we will draw this onto the VT diagram पे बने. So let me just select all these completely. रुको, I'll select this in parts. Okay बच्चा, so on the VT diagram, so देखो थोड़ा टाइम भी बच जाता है, we can save the time if we are properly using the graphics. So on the VT diagram, sir, how will we represent a constant volume process? Sir, it will be represented by a horizontal straight line. Yes sir. And now for isochloric heat addition on the VT diagram, sir, the arrow will be pointing towards the right hand side because the temperature increases, and for constant volume heat rejection, arrow will be pointing towards the left hand side. Sir, the temperature increases. And heat rejection में the temperature decreases. Now बच्चा, doing the analysis for an ideal gas. Sir, ideal gas equation क्या है? Sir, PV is equals to MRT, the ideal gas equation. So if I rearrange some terms, sir, I can say that if I am rearranging this P upon T will be equals to Mr upon V. Now, sir, what is the reason for rearranging them in this way? Sir, the reason is, let's say we are having a fixed mass of an ideal gas. So mass is constant. The value of R, which is your characteristic gas constant, is also fixed. That means these two values are constant, and we have already said that this is an isochoric process. So volume is also constant. So when your complete RHS is constant, your LHS will also be constant. Yes or no, bacha? So for an ideal gas undergoing an isochoric process, sir, P upon T is equals to constant when your volume is constant. So remember this very well, sir. For a given mass of an ideal gas undergoing an isochoric process, we can say that absolute pressure P, let me write this in this way also, absolute pressure P is directly proportional to absolute temperature. And if I want to write this in the terms of from state 1 to state 2, I can write this as P1 upon P2 will be equals to, you can say T1 upon T2. Yeah, P1 upon T1 will be equals to P2 upon T2. You can rearrange the terms and understand this properly. Now, bacha, moving ahead. So, from this we can define the first ideal gas law, that is your Gay-Lussac law. Sir, according to Gay-Lussac law, for a given mass of an ideal gas undergoing an isochoric process, that means when volume remains constant, absolute pressure is directly proportional to absolute temperature. याद रहेगा, absolute pressure is directly proportional to absolute temperature. Is this clear? Very very important. This is our first ideal gas law, जो आप लोगों को पता होना चाहिए. Okay sir. Moving ahead, sir, draw the PT diagram for an ideal gas undergoing an isochoric process. Now, what is this PT diagram? Pressure versus temperature diagram. Sir, pressure onto the y-axis and temperature onto the x-axis. So बच्चा लोग, let me explain you a very basic mathematics. थोड़ा basic maths अगर मैं आप लोगों को पढ़ाने की कोशिश करूं, then how can you define the slope of a given process? Sir, the slope is always defined by the y-axis coordinate upon the x-axis coordinate. Sir, the y-axis coordinate upon the x-axis coordinate. So for the PT diagram, sir, pressure is the y-axis coordinate and the temperature is the x-axis coordinate. P upon T. Pressure is the y-axis coordinate and the temperature is the x-axis coordinate. Yes or no, bacha? So can we say that the slope of an isochoric process on the PT diagram will be equals to P upon T? Will be equals to P upon T? Yes or no, बच्चा? Will be equals to P upon T. So बच्चा अभी अपन लोगों ने define किया that P upon T was equals to mr upon V. So can I write this over here once again? Sir, P upon T will be equals to m into r upon V. So बच्चा let's draw this, and now बच्चा it is a constant. This value is constant. So how do we draw a line of a constant slope? Sir, it will be a line inclined at an angle of 45 degree from the origin. It will be a line inclined at an angle of 45 degree from the origin. But bacha, we cannot have a zero volume, so this line can never be from the origin. Remember the basics. Okay, bacha? So this will be this way. And what will be the slope of this line? So this slope is equals to mr upon V, and if I apply the ideal case equation, sir, mr upon V can also be called nr bar upon V. It can also be called nr bar upon V. Is this clear, bacha? Okay, I hope this point is pretty clear. So आप लोगों को दो equation याद रखने. Now, sir, how we will represent isochoric heat addition and isochoric heat rejection? See, we are explaining you around half an hour for a single process. So you can understand the importance of this topic, because when you are understanding every process and when you are studying any of the cycle, whether it is a Carnot cycle, whether it is a Otto cycle, whether it is a diesel cycle, you are very clear how to represent it onto the different diagrams of thermodynamics. So let's draw the isochoric heat addition. Let me take a page over for you. Okay, let me select this. See this? Sir, for isochoric heat addition, and isochoric heat rejection, bacha. So बच्चा, when we are having isochoric heat addition, हो क्या रहा है sir, the temperature and pressure both increases. Temperature increases and pressure also increases. Okay, एक ही मिनट. Temperature increases and pressure also increases. So बच्चा लोग, what will be the direction of arrow? Sir, the arrow will be pointing upward, यहाँ से लेके 1 to 2 like this. Is this clear? 1 to 2 like this. And for heat rejection process, sir, the temperature will decrease. Sir, यहाँ पे for isochoric heat rejection, for actually it is for ideal gas only, undergoing an isochoric heat rejection, बच्चा. So what will be the point? Sir, the pressure and temperature both are decreasing, so this arrow will be pointing towards downward. Is this clear बच्चे? यहाँ तक समझ में आया? So with this we have tried to cover, I have tried to cover most of the points of isoporic process. Now बच्चा लोग let's jump on to the next topic. यहाँ पे actually we are not directly jumping onto the constant pressure process. Let's discuss on what parameters the pressure exerted by a gas depends upon. So मैं एक छोटा सा analysis आप लोगों के लिए करना चाहूंगा. Okay, what I want to do is a छोटा सा analysis. छोटा सा analysis means let's say if I am having a container. Sir, let's say if we are having any, you can say gas inside the container. Let me draw the molecules of gas. So बच्चा, how do we physically understand कि pressure है क्या? Sir, pressure is the force exerted by the given gas per unit area. So if you want to understand what is the pressure, if you want to feel what is the pressure, so I can say that one thing, the force with which the molecules will be striking onto the walls of the container per unit area will be indirectly representation of the pressure of a given gas. Because अगर आप लोगों को पता है, basically we are discussing about two types of thermodynamics. One is your classical thermodynamics and one is your statistical thermodynamics. So here in mechanical we are more of focusing on to the classical thermodynamics, where we discuss about the average or gross behavior of the molecules. We are not going at the microscopic level, that is for the statistical thermodynamics. So बच्चा लोग, if you see this, यहाँ पे first thing is that according to the kinetic theory of gases, if you know that very well, that kinetic energy of the gas is represented by 3/2 kT, where K is your Boltzmann constant. K क्या है आप लोगों का Boltzmann constant है, and T is the absolute temperature. And T is the absolute temperature. First of all, is this clear बच्चा? तो आप मुझे एक बात बताइए, what is the actually the formula? What is actually the formula of your, you can say, kinetic energy for, you can say, any of the, you can say, conditions? So it is the 1/2 mc square. यहाँ पे we are not using V for velocity. In thermodynamics we are using the symbol C for velocity. Okay, so 1/2 mc square will be equals to 3/2 kT. Now if you see this very well, from this can I say that the square of the velocity, that is c square, is directly proportional to the temperature? Sir, the square of velocity is directly proportional to the temperature. Yes or no bacha? C square is directly proportional to the temperature. Can I say this bacha? So if the temperature increases, sir, the velocity of the molecules will increase. Molecules में मचेगी अफरा तफरी. Okay, the molecules will have a random movement. And ultimately the force with which they will be striking the container wall will increase, so the pressure will also increase. Okay sir, this is one thing. So second point is that what if I increase the density of the gas? Now how can I increase the density of the gas? Sir, this is only possible if I'm increasing the, you can say, mass of the gases, which is indirectly increasing the molecules. So यहाँ पे अगर मैं और molecules डाल दूं गैस के, अगर और molecules डाल दूं, let me represent them by a separate color, एक specific region में ही करते हैं. So यहाँ पे the density is increasing. See this? सर यहाँ पे डेंसिटी इंक्रीज हो रही है. यस सर. So when the density is increasing, the number of molecules striking onto the container wall will also increase. So the point is, sir, increasing the number of molecules, sir, increasing the number of molecules, sir, the density increases. Sir, and ultimately the pressure increases. ओके बच्चा, क्या आप लोगों को ये समझ में आया? सो बेसिकली यहां पे आप लोगों को चीजों को समझना जरूरी है. आई विल मेक अ कंक्लूजन फॉर यू दैट एज द टेम्परेचर इंक्रीजेस, sir, the pressure increases. And बच्चा, as the density increases, sir, once again the pressure increases. Once again the pressure increases. Is this clear बच्चा? So finally I can conclude before ending up this video that pressure is directly the function of temperature and density. So bacha, remember this very well. As the temperature increases, the pressure will increase, and as the density increases, the pressure will increase. So bacha, I would like to conclude this video over here. In the upcoming part of this video, I'll discuss about the constant pressure process, isothermal process, adiabatic process, and polytropic process. I hope you like the video. Thank you for now. For now, this is SHAILESH Sir signing off. Do like the video and share it with your friends. Thank you.